So again, we are going over solving systems of equations by graphing today. When you graph these functions, do yourselves a favor, put them in slope-intercept form first. It's going to be the easiest thing. Remember, if it's in slope-intercept, it's y is equal to mx plus b, where your b is your y-intercept, your m is your slope. Plot the point for your y-intercept first, use your slope to find the next points. With these, it is probably easiest for you to plot as many points as you possibly can on the coordinate plane, so you have an exact intersection for these two functions that are going to be graphed on the same coordinate plane. So if we look at number 1, we have y is equal to 2x minus 3 and y is equal to negative 3x plus 2. We're going to graph the first equation, that y is equal to 2x minus 3. Our y-intercept is that 0, negative 3, so we're going to put our first point at 0, negative 3. From there, our slope is 2, so we're going to go up 2 to the right 1. We're going to do this throughout the entire coordinate plane. So that way we have a line that goes through all of these points. And when we go to graph our next line, we will have a specific point that these two lines intersect at. For your second line, you have, or your second function, you have y is equal to negative 3x plus 2. So your 2 is your y-intercept at 0, 2. Plot that point first. From there, you're going to go down 3 to the right 1, down 3 to the right 1, or up 3 and to the left 1. From here, you draw your line through the points. You see that the intersection point is right here, so that ordered pair, which is 1, negative 1, is your answer. For number 2, we have y is equal to negative 5/3 x plus 1 and y is equal to negative 1/3 x minus 3. So plotting the first function here, we have a y-intercept of 0, 1, and our slope is negative 5, 3. So we're going to go down 5 to the right 3, plot that next point. For this, our line's going to look similar to this. So when we go to plot the last one, our y-intercept is at negative 3. We go down 1 to the right 3, or up 1 to the left 3. Draw the line through those points. And our solution for this one is 3, negative 4. The next question we're going to look at is number 3. We have y is equal to negative x plus 1 and x is equal to 3. For that y is equal to negative x plus 1, we're going to have that y-intercept at 0, 1. Then we're going to go down 1 to the right 1. From here, we draw our line through these points. And then we graph that x is equal to 3. When x is equal to 3, that's a vertical line through that number on the x-axis. So it's going to go right through 3 on the x-axis, which means our point of intersection here is at that 3, negative 2. If we look at the next page, number 7, we have y is equal to 4/3 x minus 3 and y is equal to 1. For that y is equal to 4/3 x minus 3, our y-intercept is going to be at that 0, negative 3. And we have a slope of 4/3, so we're going to go up 4 to the right 3. We plot those points. We draw our line through them. And then we graph that y is equal to 1. Y is equal to 1 goes through 1 on your y-axis, not your x-axis. So we're going to have a horizontal line through 1 on the y-axis. Your 2 points that are the same for both of these functions are at 3, 1. Next, we are going to look at number 12. For number 12, we have x minus 4y is equal to negative 4 and 5x minus 4y is equal to 12. First thing we're going to do is we're going to take this x minus 4y is equal to negative 4, and we're going to solve it for y. So we're going to move the x over by subtracting it from both sides. We have negative 4y is equal to negative x minus 4. And then we're going to divide each side by the negative 4. So this gives us y is equal to positive 1/4 x plus 4. So when we go to graph that first function, we're going to have a y-intercept at 0, 4, and then we have a slope of 1/4. So we're going to go up 1 to the right 4. Oh, I'm sorry. Thank you. It's plus 1. So this should be plus 1. So we're going to have a y-intercept of 1, 0, 1, and we're going to go up 1 to the right 4. We can also go down 1 and to the left 4 as well. Draw your line through the 3 points. And then work on the second function. The second function, you have 5x minus 4y is equal to 12. We solve for y, moving the 5x to the other side by subtracting it from each side. We have negative 4y is equal to negative 5x plus 12. Then divide each side by the negative 4. So we have y is equal to 5/4 x minus 3. So we have a y-intercept of that 0, negative 3. Then we're going to go up 5 to the right 4. We draw a line through those 2 points. And we see that the intersection point here is that 4, 2. For the next one, on the next page, we're going to look at number 16. I think that, yeah. We have x minus 3y is equal to negative 6, and 2x minus y is equal to 3. So looking at that first function, that x minus 3y is equal to negative 6, we're going to subtract the x from each side. We have negative 3y is equal to negative x minus 6. We divide each side by the negative 3. We have y is equal to positive 1/3 x plus 2. So we have a y-intercept at 0, 2. From there, we're going to go up 1 to the right 3, or down 1 to the left 3. We draw the line through those points, and then we move on to the next function. The next function we have is 2x minus y is equal to 3. We're going to subtract the 2x from each side. We have negative y is equal to negative 2x plus 3. We then divide each side by the negative 1. Changing the signs on everything, we have y is equal to positive 2x minus 3. So that's going to give us the y-intercept of 0, 3, or sorry, 0, negative 3. From there, we're going up 2 to the right 1. We also go down 2 and to the left 1. We draw our line through those points. We see that we intersect at 3, 3. So our answer is just the ordered pair 3, 3. If we look at the next page, we're going to be looking at number 21 first. It gives us negative 6x plus y is equal to 4, and negative y minus 2x is equal to 4. We're going to start with that negative 6x plus y is equal to 4. We're just moving the 6x over by adding it to both sides. So we have y is equal to 6x plus 4. From here, we're going to go up to 4 on the y-axis, put our first point. We cannot go up 6 into the right 1. So we're going to do the opposite of that and go down 6 into the left 1. We have our 2 points here. So we draw our line through them. And then we go to figure out the next function. We have negative y minus 2x is equal to 4. For this one, we're going to start by adding the 2x to both sides. We have negative y is equal to 2x plus 4. Then we divide each side by the negative 1. And we have y is equal to negative 2x minus 4. So for this one, we're going to have a y-intercept of 0, negative 4. And then we're going to go down 2 into the right 1. Again, we cannot go down into the right since our coordinate plane is not that big. So we're going to go up 2 into the left 1 instead. We draw our line through those points. We see that these two lines intersect at the ordered pair -1, -2. So our answer is just -1, -2. Next, we're going to look at number 23. 23, we have 0 is equal to -3x minus 4 minus 2y, and 2 minus 1/2 x is equal to y. For that first function, that 0 is equal to -3x minus 4 minus 2y, we can just move the 2y over to get it by itself. We would have 2y is equal to -3x minus 4, and then we can divide each side by the 2, and we have y is equal to -3 over 2x minus 2. So for this one, we have a y-intercept of 0, -2, and then we're going to go down 3 and to the right 2. We can also go up 3 and to the left 2. Once we have those points, we can draw our line through them. And then we can work on the second function. That second function, you have y is equal to -1/2 x plus 2. So we just rearrange the order from it, so that way it gives us the equation in slope-intercept form. So we have a y-intercept of 0, 2, and then we're going to go down 1 to the right 2. We can also go up 1 to the left 2. We draw those points, we get that line through them, and we see that our point of intersection is at -4, +4. For the next one that we're going to look at, the last one that we're going to do is number 29. For 29, you have 2x is equal to -8 minus 2y, and -2y minus 8 is equal to -2x. If we take that first equation, that -2x is equal to -8 minus 2y, and we solve it for y, we can move the 8 over by adding it to both sides. We have -2y is equal to -2x plus 8. From here, we're going to divide each side by that -2. So we have y is equal to +x minus 4. This one gives us a y-intercept of -4. So first point at 0, -4. From there, we're going to go up 1 to the right 1. We draw our line through those points. We move on to your second one. Your second equation, you have -2y minus 8 is equal to -2x. Start this one by adding the 8 to both sides. You have -2y is equal to -2x plus 8. From there, divide each side by the -2, and you have y is equal to x minus 4. So again, you have a -4 as your y-intercept and a slope of 1. So these two lines intersect at every single point. So because they overlap each other, you have infinitely many solutions. If you do get two lines that are parallel to one another, which means they have the same slope but different y-intercepts, those will not have any solution. So if they are the same slope, same y-intercept, they're infinitely many solutions. If it is the different y-intercept but same slope, then those two lines are parallel to one another and they will never intersect, so it would be no solution.